Hello, my friends of Qatari Labs. My name is Paul Montoya. Please welcome to this webinar. This webinar is in geological modeling of sedimentary layers from geospatial rasters with Python and Gempy. Okay, so we need to install Gempy, and in order to install Gempy, there are some tricks here. Okay, that I don't know. I mean, it's really hard to install Gempy from the beginning. So because there is some the compatibility issues and so on, um, and even that the version of Gempy has changed, and it might have changed, for example, in 2 weeks, or 3 weeks. So in order to do that, first I'm going to give you to give you this URL, and we have to install a okay, so we have to install some package, so Python Qt, Python pip, and so on. So we install that. Okay, so the command is on the chat. Okay, there is no Python Qt 4. Um, well, so we need to so we need to lsa. So we need this local, okay? Yeah, because sometimes it's not created, okay? And wait. Okay. Sorry, I was missing off. I was confusing myself. Okay. Sorry for the last part. Okay, so yeah, don't worry. No, that was not the, okay, so let's do this again. Clear? Okay, first we update, okay, then we install the Python pip in case that you don't have it. Then we install the Jupyter core. I don't know exactly why we have to install the Jupyter core, but okay. Okay, and then we install some library for the visualization. Okay, and then we have to see the global variables. Okay, okay. And for example, in my case, I have home Hatari local ping, and this has to be your username, okay? Because Hatari is my username, okay? This has to be in the path, okay? In case that is not on your path, you have to export that to your path. Otherwise, Jupyter Lab won't run, okay? So you have to do home, okay? And this has to be your username. So in my case is Hatari, and this is local, and this is Bing, and this is path. Okay, export home Hatari local bin path uh, without the spaces. Okay, so and now if you do echo path, you have to this has to apply here. And in my case, I have it twice. Okay, don't worry. Okay, if you are here with me, please type 1. If you are here with me, please type 1. Dur, Jefgen. Okay, great. So then we install PyVista. Pip install PyVista equal to this version. The problem with PyVista is that even that the GenPy version is, I think that it's in the latest. Uh, the problem is that PyVista has a lot of new versions, and with the problem of having a lot of new versions, that GenPy that is not that. I mean, the latest version maybe is from 6 months ago, is already incompatible with the latest version of PyVista. So that is why we have to install PyVista on this version. Okay. And it has a problem here that GenPy 2.3 requires PyVista 0.9. Okay, so and this is different from our case, so let's install what it says 0.39.1. Okay, following the recommendations. Okay, so this is the PyVista version. Okay, yeah, come on, Jeff, don't be so lazy. Okay, with that, with having that, we install pip install GenPy and Jupyter. Okay, and with this, we install pip install GenPy and Jupyter. Okay, great. If you are here with me, please type 2. Okay, so you have on the description of the on the webinar, you have the data for this, and the data for this webinar is here. The data for this webinar is here. Okay, so is and you have to place it on geological model of sedimentary region. You have to place it here on your documents. If you have inserted there in your documents, please type 2. Okay. Okay, Ali, Jefgen, Muhammad. Okay, great. So please you have to insert it here. Okay. So if you go back, so say cdmnt. So we are going to the C drive to users, and then here you have to apply your user. My user is Aulem, but your user, this is your user of Windows, and this is exactly what appears here. See user, and this is has to be your user. Okay, so please find your user. Okay, documents, and then webinar on geological. Okay, so you have to be here. If you are here with me, please type 3. If you are here with me, please type 3. Muhammad Jefgen. Okay, great. So yes, please type 3. Okay, so Jupyter Lab. So we launch Jupyter Lab from here. We launch Jupyter Lab from here. And here we can copy and paste this one into a browser. Okay. Okay, and here we have some data. So let's explore the data. Okay, and if you want to, okay, maybe you have it already. Settings theme, I'm on Jupyter Dark. Okay, so on the txt I have some JSONs. Okay, and the first one is that the lay one will be is refers to this one, the lay 2 to this one, and the lay 3 relates to this formation. Okay, so there are three formations. Okay, and we also have some model orientation. Okay, that this is a okay where from where you get this model orientation. Okay, so we need the orientation of the layers and this is required for the interpolation. Okay, we are going to do this. Okay, this is what you have in the txt. Then you have the rasters that are the rasters of the surface and the different bottoms. And there is also the scripts, that is where we have the backup scripts. And also we have the shape file that this is for the this I mean we are going to use a plugin that has a three point. So we have this, so we have a shape file of 3 points, and that's it. Okay, if you are here with me, please type 4. So please open your QGIS. If you don't have QGIS now, don't worry. You can, okay, so okay, so I'm going to duplicate. So this will be my backup. Okay, great. If you are here with me, please type 4. Uh, no, actually no, no. Because the plugin it works only in QGIS. Okay, Jeff Ken, are you there? Jeff, Jeff, Jeff Ken. Yeah, please type 4, please. Okay, so we are going to open the from the documents we can find the webinar, and then here we have the shapefile where we have the example points. Okay, great. These are the example points, and then we have the rasters where we have the DTM, the layer bottom 1, the layer bottom 2, and the layer bottom 3. Okay, in this order. Okay. Okay, great. No, Muhammad, you cannot use, because why not? Because we are going to use this. And Muhammad, forget about those licensed software. I mean, we use always open source software. Okay. So there is a 3-point method. Okay, there is a here in all you have to use for, you have to look for the 3-point method and then you have to install it. Okay, you have to install it. If you have installed it, please type uh, sorry, I am here. I don't know what happened. Yeah, okay. So I continue sharing my screen. Okay, great. So we have to install, please install the 3-point method. Okay, please install the 3-point method. If you are here with me, please type 1. If you are here with me, please type 1. Jefgen, Jehen. Okay, Nur, great. So here we have this plugin, and then, okay, so what does it say? Okay, the plugin uses 3 methods because it actually does interpolation, and it gives you the ASCII, which values does it give you? Let me check. And it gives you the azimuth and the dip. Okay, they give you the azimuth that they give, and the polarity is just 1. Okay, so let's see here. Okay, so and then we need a point that will be the centroid of these 3 points, and it will have the dip and the strike. Okay, so let's calculate that. Okay, don't worry, because you can copy what we are going to calculate here. Okay, so let's see, let's work with, okay, so let's go here to the 3-point vector, 3-point method. Okay, so the input file will be the example points, and the dem layer will be for the bottom of layer 1. Okay, for the bottom of layer 1, and this will be in the webinar on shapefile on output as a bottom of layer 1. Okay, so this will be the output file. Okay, great. So we run this. Okay, and it gives you the centroid. Okay, and as well the bottom of layer 1, and this is how you are going to deal with. Okay, uh, first we go to the centroid. Okay, and then we copy this. uh, we copy the centroid value. We copy, wait a minute. Okay, Okay, okay. Now I'm here. Yep. So here we have the, for example, we have for the bottom of the first layer, okay, we have this is the easting, this is the northing, and this is the elevation, okay, okay. So these are the values that you are going to copy and paste here. And the deep, where is the deep? The deep is here. If you open the attribute table, this is the deep. No, this is the strike and this is the deep. And here, this is the strike and this is the deep. I just place it with just 3 decimals, okay? But, well, and the polarity is 1 and this corresponds to this corresponds to this value, and this value, okay? If you are here with me, please type 2. Okay, so this is how model orientations is calculated with the use of, okay, and this is for the first layer, and this is for the second layer, and this is for the third layer. Okay, if you are here with me, please type 3. If you are here with me, please type 3. Great. Okay, so, well, we can close this. Well, actually, okay, so this is how, well, actually, I don't need that because I haven't removed this. I have told you which are the procedures, and then we go to scripts, and then we create a new notebook that is webinar 1, because this will be the first part of the webinar 1. Okay, okay. If you are here with me, please type 4. If you are here with me, please type 4. Okay. Mhm. So in webinar 1, yeah, we are going to work with Gempy. So import Gempy as GP. Import pandas as PD. Import matplotlib.pyplot as PLT. From gempy.plot import plot. Yes. And import rasterio. Import JSON. Okay, so these are all the package. Okay, I use Shift Enter. You can run the cell like this as well. Okay, if that cell has run, please type 5. Mhm. If that cell has run, please type 5. Waiting for you guys. Okay, great, Sisai. I mean, the link of this video will be available at the end of the webinar. Okay, so if you wait till the end, otherwise you have to look for them as in our Patreon site. Okay, rasterio.open. Okay, so we open with rasterio, we are going to open the DTM top Okay, so we open the file, but we want the array. I mean, we want the array. So for that, we read, okay, we read the file, okay, because there is something different in between opening and reading. So we read the file, and then there is the first one and the only one, and then we can show the array at the first, okay, and this is our array. Okay, great. If you are here with me, please type 6. Mhm, mhm. Okay, so let's continue. So we have a elevation dict, okay? To store the elevation arrays, okay? We create an elevation dict, and here in elevation dict for the first layer, it will be rasterio.open, okay? So um, rasterio.open, the bottom rasterio layer bottom one.diff. Okay, so we open that, and then we open that, and then we read the first layer. So this will be the second key, the third key will be the layer 2 and layer 3. Okay, so and then we can as well have a sample of the third layer, of some values of the third layer. Okay, and then we see that at the bottom the elevation is minus 28. Oops, 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 oops. Ah, okay, sorry. Okay, this. Okay, if you are here with me, please type 7. Okay, great. So max elevation is equal to, Okay, so we need a reference. Okay, what we need is some reference for because we are going to create a geological model, and the geological model needs some reference from the top and the bottom, and because that the top has to be the top of the elevation, the them, and the bottom has to be the minimum of the bottom elevation. Okay, in order to do that, uh, we do maximum elevation is equal to uh, top m array top m array dot max, and then this is a trick just to make it multiple of 2 because actually we don't need that the top is 1.64 because actually we need that our voxels or the generated cells are multiple are located in some known, I mean it's not exactly necessary but it's more clear to understand. Okay, okay, so that is why we with this trick, so we get, so this is the minimum divided by 2 times 2, so and then we get, so max LF min LF. Okay, so we have that the top will be 40 and the bottom will be 30, and those both are multiple of 2. Okay, great. If you are here with me, please type 8. Mhm. So, and then we create another dict, gempy dict, and this will be as well as a dictionary where the gempy dict maximum, the key maximum elevation will be the maximum elevation, and the gempy dict of minimum elevation will be minimum elevation. Okay, great. So with that, we have created another gempy dict. Okay, I always use Muhammad. I use the times two in order to because okay, there is a question why I do this because the top m max is this value that is decimal value, and it has a lot of decimals, but I don't want that my geological model will be discretized on this with this value. So I want a multiple of 2, the closest multiple of 2, and with if I just type it, it will get the closest multiple of 2. Is that understood, Muhammad? Muhammad? Okay, great. Great. So we have to get the, okay, from the raster we have the transform, that those are properties of the raster. We can get the size, and we can get as well the thickness of the layers that we are going to generate. Okay, and this is X and Z. Okay, wait me a little bit. Mhm. Okay, so this say print, and then we can apply to our gempy dict the nxe is equal to nxy, and to gempy dict of nz is equal to nset. Okay, so well and this is gempy Okay, great. So we have this the discretization, okay, because 10 is actually the cell size and 5 is the defined layers of that we want in our geological model. Okay, and then we have the gempy dict of min x. Okay, where we are going to get the min because actually our geological model is not, it doesn't go from 0 0, actually goes from, it has some boundary, so that is why we have tom file dot bounds dot left. Okay, and then we, okay, and then the max x min y max y. Okay, and this is left, right, right, and this is bottom, and this is top. Okay, and then if you want to see the values, you can apply the gempy and these are the values of maximum elevation, minimum elevation, the size, and the min and max. Okay, if you are here with me, please type 9. I'm going to comment this. Okay, Ali Sisai. Okay, so here on JSON object, is JSON dumps the gempy dict and the indent is equal to 4. So we are going to store the our JSON where we store in the txt output, and this will be gempy dict.json. Okay, in module with write as out file, and then here say out file dot write JSON object. Okay, great. Okay, so with that, what we have generated here on txt on output, we have generated this gempy dict. Okay, because we want to store this for future interpretations. Okay, if you are here with me, please type 10. 1 1 1. Okay, great. So then we have the top m array dot shape. So, and then we see that we have 150 rows times 150 columns. And then we are going to import the little dict is equal to json.load. And then here, where is the little dict? Is on txt. And this is the little dict.json. JSON load the open. So the little, I usually use a capital letter just to separate words. So here they are the little detail. Okay. Great. So point df is equal, so we create an empty data frame, pd data frame. You can make all your questions here, columns of, and then our columns will be x, y, z, okay, and formation. Mhm. Okay, great. Okay. So we have, this is an empty data frame. If you are here with me, please type 2. This is an empty data frame. Okay, great. So we have rows. What we are going to do now is that we are going to extract, okay, we are going to extract according to a multiplier. What is the experience here? Okay, so you have a layer that has 30 values, 30 rows and 30 columns. So it means that you have 900 points. But if you are going to use these points in Gempy, this is actually a lot. Okay, so maybe it's possible if you run it that in Linux. Okay, but in Windows, in the Windows subsystem for Linux, actually the problem, it breaks. I mean, like you start calculating for all of these points and the software breaks. And that is why we, instead of using, okay, uh, one each cell, we are going to use one value each 10 cells, okay, and that is something that we are going to use. You can try this. I mean, if you are running in Windows natively with more points, and then you can assess which will be the quality of your interpolation, okay. However, this is something for you to calls, rows calls is equal to. Mhm, mhm. Well, actually, I don't know why, but this is okay. So we use cell multiplier, okay, and then we are going to use 10, okay, because we are going to use one value each 10 cells, okay. We indeed here we use a counter and say for layer in litodict for row in range of rows, okay, if row the integer divided cell multiplier is equal to 0, so that means if it is multiple of 10, okay, 2 points, for call, and then for call in range the calls, if call the integer division cell multiplier is equal to 0, and say row values is equal to, and then we open a dictionary here, okay, where the x value is equal to top and file. Mhm. Okay, okay. The X and Y is actually come from top and file, but the Z is actually come from the elevation directory. Top XY row call 0, okay, comma, Y, okay, and this is for 1. And the set values, okay, it comes from the elevation dict, for the given layer, okay, great. Mhm. For row call, okay, so this is the elevation values, okay, the set values, okay, and the formation will be little dict of layer, okay, layer, okay, great. And this is an index because this is a little dict. Home. Let me check. What little dict is a dictionary, but if I use 0, no. For layer. Because this is a iteration over the little dict. Yeah, that is why. Row series, we create a row series is equal pd series. Yeah, series row values. Okay, and this is point df log of length of point df. Okay, this is just something to add a row to the value. Row series. Okay, and then here we increase the counter. Okay, great. So what this will do is that it will take the x, the y, the set for the given. It will take the set for the given layer, okay, and as well it will give you the formation, okay, and it will store as a series, and then it will add to this add will add a row to our data frame, okay. So we can run this and it will take some time. Okay, it has finished. Okay, and then we can call our point df, and this is our point df, and this is just the first value, but this is our xyz and the formation for all for the centroids of all row, all cells, multiple of 10. So this is 30 by 30, so the shape. So we have 675 uh, values here. Okay, if you follow me here through here, please type 3. If you follow me here, please type 3. Yes. Yes, 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 yes. Yeah. Amsterdam time. Now, because, yeah, Amsterdam time. It's already 7 p.m. in Amsterdam time. Okay. But don't worry, the video will be available at the end of the or did I make a mistake and more people will arrive? Okay, okay. Yeah, don't worry. So, Portugal, you are from the place of the vino verde? Vino verde? Yeah, good stuff, huh? I like this one. The- Okay, so CSV is equal to txt, okay, output, and then we got, well, we have to export .csv, okay. So we have to export this to, and then we create here on outputs, we create the model point. I mean, we store the pandas data frame as the model point. Okay, great. So here we have. Okay, so what do we have? We have a dictionary that it has some information related to the grid and it has information related to the uh, we have information that is related to the grid or we have information that is related to the extension and also to, yeah, mostly to that. And then we have a CSV file that has XY and the formation, and this is kind of 600 lines. Okay, we have a, okay. But, okay, and with this, we are going to use these values together with these values, together with the orientation, okay, in order to construct our GenPy model, okay? And in order, Victor, you can do this because actually we are going to open a new, we go here to scripts, okay? And here we can open a new, well, I don't know if you have Windows Subsystem for Linux, but okay. We can open a new launcher that is renamed Webinar 2. Okay, great. Okay, great. Yes. Okay, so let's see the second part. So it's here we use import GenPy as GP. Okay. In the other notebook, we actually didn't have uh, matplotlib.pyplot as plt from genpy.plot import plot. Okay, and in the, if you remember, in the other notebook we haven't used genpy. Now we are going to use import numpy as empty. Shift enter. So we can check the version, and this is handful if you are working with as GP. Okay, so we are in version 2.3. Okay, and then we import the JSON files. Okay, and we import the JSON files as dictionaries with JSON load. Okay, these are utilities of Python that sometimes you Google it, but with time it's more handy that you have those in mind. Okay, so output and then here Gempy JSON. You work much faster. Okay, R. Okay, great. So this is GEMDICT, and this is the dictionary that we have imported as a with the JSON that we have imported as a dictionary. If you are here with me, please type 4. Okay, great. Okay, great, 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 great. gp dot create model the geo. Okay, so we are working with Gempy. So we create our geo model. Shift enter. Okay, so this is our geo model. And then okay, so here in the GMD, okay, here we are going to tweak some things, okay, because our even thought that the size of the raster was of 10, okay, maybe this is too much for us, okay, so we are going to use the size of the of our model will be 20, okay, and even though that we have the thickness of the layer was 5, so we can say okay, here the thickness of the layer will be and set will be just 2. Okay, great. So this is something that you can define for your own research or for your own purpose. Okay, if you are here with me, please type 3. Just one question, Victor. Are you related to a university in Portugal? Sorry? Yeah. Are you related to any university in Portugal? Okay, cool, cool. No, I tell you that because. Hmm? Okay, cool, cool, cool. No, this because we usually, well, I did uh I did some classes in the University of Being and as well in the University of Alcalá. And well, maybe we can chat in the future if we can arrange to do some workshops or something in Portugal. If it's that, if you're interested. No, no, no. Yeah, we can continue talking through emails and because it's actually something that we do when we have the time and it has to be arranged with. Uh, Well, maybe for 2024, I mean, not for this year. Okay. Yeah. Okay, so this is well, okay, what we are going to do now is that we are going to define this number of cells and the number of columns, okay? And this is the topic. We have, what we need is that we define the number of cells and the number of columns related to this discretization, okay? So that because it's not the same as what you have in the previous one, that you have in the previous one, we have that the raster has a discretization of 10, okay, and now we are going to, okay, but now we have that our cells of the geological model will be 20, so that is what we are going to gemdict of min x, okay, divided by gemdict and nxy. Okay, great. Y max y min y, okay, and as well for the end set. Well, the end set, the number of formulas of set is the max elevation, the minimum elevation, yeah, and divided by end set. So this will be the print of nx, ny, end set. Okay, that's it. Great. So this is, okay, this is for your geological model. So you have 35 rows, 35 columns, and 75 rows, columns, and 35 layers. Okay, if you are here with me, please type 4. Okay, so it's a GP init data. So it's a geo model. Okay, so, and this, okay, if you want to know more information, so you can just type this because actually, so we need the GMPy, geomodel, the extent, the resolution, and the path to the points, the contact points, and the path to the orientations. So these are the two of them. So that's what geomodel. Okay, so these are the extensions. So it's gemdict minimum x, okay, comma, gemdict maximum x, okay, minimum x, maximum x, minimum y, maximum y. Okay, and then we continue here because this is gemdict minimum elevation, and this is gemdict maximum elevation. Okay, so these are the extension. This is the extension of our model. Okay, great. So, and then here will be nx, ny, and z. So we have the path to the contact points path E is equal to, okay, so to the txt output and model points dot csv, okay, and the path to the orientation is equal to txt model orientations, comma, and the default values, well, is equal to true, just in case that you are missing some value. Okay, and with that, you have created your first geo model. Okay, if you are here with me, please type 5. Who else is here with me? Please type 5. Okay, great. So here what we are going to do, so if we open geo model dot surface, okay, so we have, this is the order, okay, okay, this is the order, sandy, loamy, sand layer. Okay, but let's see on the Gempa in the little dig, the order is sandy, loamy, reborns, sand layer, and moss and this one. Okay, sandy. Okay, so it's in the same order. Okay, however, this can be in any order. So we have to specify. Okay, we have to specify the order, okay, because you don't want that some, I mean, that you don't want to specify that older layer is actually on top of a younger layer. So it's a GP map stack to surface of geomodel, okay, and this is strat series, okay, and on the strat series you gave specifically the order, so this is sandy loamy overburnens, comma, sand layer, comma, and then this formation, comma. Close this, comma, and then we if you have a series that has not been defined here, it will remove with this option, remove, and you set series equals to true. Okay, great, that is amazing. And then we run this, and then, well, we have the same because it's in the same order, but you can have it in any order. Okay, great. If you are here with me, please type 3. Okay, great. So we can have the grid as well. There is, okay, there are many options of the package, so we can have the grid. This is a tool that can give you the X, Y, and Z of the grid. Okay, and then we have fig is equal to plt.figure of fig size of 20 times 20. Okay, plot is equal to gp dot plot 2d of geomodel. Okay, show lit is equal to true. Show boundaries is equal to true. Vertical exaggeration 10. Well, and here we define the fixed size again, that is, so if you define the fixed size here, you are not required to define it here. And the legend is equal to true. And then here plt.show. Okay, and these are the contact of the sandy loamy layer, the sand layer, and the this formation, and these are the orientations. Okay, because we are what we are doing is a cross section on a given in the given at the half of the y, I mean of the y extension. Okay, so if this is square, it's at the half. Okay, so if you're here with me, please type 4. If you have any questions, let me know. And it will interpolate, the model will interpolate from these points. Okay. Okay. So let's say gp.set interpolator of geomodel. Okay, great. Okay. Uh, there is a question from Noor that says, these centroids, those are centroids, okay? Why? Because actually those come from this XY that give you the centroid of the column, okay? Great. Okay, so we have the interpolator, so we have set up the interpolator. We have set up the interpolator. We can get the variables of interpolation. Well, okay, these are values of the interpolation in case that you want. And then we can compute the interpolation. This is something that we are looking for. gp dot compute model, okay, of geomodel. Okay, great. So with that, we compute the model. Okay, and it's taking some time. Once it has finished, please type 5. Once it has finished for you, please type 5. Anybody that has some problem, please let me know. Okay, it has finished for me. Once it has finished for you, please type 5. Okay, great. Okay, so and then which is the solution? The solution is a matrix, yeah, that give you an ID. The solution is a matrix that give you an ID to each cell. Okay, okay. So well, you can have so the values matrix. Okay, so we have 196,875 cells or vortex. Okay, and then we can see our geo is equal to gp dot plot 2D of the geo model show data is equal to true, vertical acceleration is equal to 10, plt dot type layout and plt dot show. Okay, great. And this is okay, so this is the sandy overburn. Okay, this is to the not to the surface, but this is to the top of your geological model. Okay, okay, this webinar is actually the first part of a coming webinar where we are going to apply uh, this geological model into a groundwater flow model. Okay, so for that and for that we don't have to worry about that if we are working on top of surface or not, because what is important is when we shift or we translate this model to the groundwater flow model, actually there is where it has to be consistent with elevation. Okay, if you are here with me, please type 6. Okay, and okay, it plot dot export to VTK of the geo model, and the path will be to VTK geo model. Okay, so this will export as a geo model as a VTK, and here we have the geo model. Okay, great. So we can open the ParaView to see our we can open ParaView to see our interpreted value. Great. So here we explore with ParaView. Where is this? My documents, the webinar, the VTK, and here we have the block. Actually, well, there are some surface, and this is on lithology, and this is on surface, and then we can give you here some 10. Okay, and this is the geological model. Okay, if you are here with me, please type 7. If you are here with me, please type 7. Okay, great. So, okay, so here we have our geological model as VTK, but in order to transform this to the groundwater flow model, what we will need is an XYZ litho of every vertex here. Yeah, so for that we are going to we are print sol.lit block shape, no, lit block dot shape, okay, which is the shape of the lit block, and sol dot grid dot values shape. Okay, so we have this amount of cells. Okay, in this array we have just the lit, and then in this one we have the XYZ. Okay, so we are going to reshape. We need, in order to join this, first we need to reset the lit. So lit reshape is equal to sol dot lit block dot reshape. Okay, reshape of sol dot lit block dot shape 0 and 1. So it's lit reshape. Okay, so this is the reshaped version. Okay, this is just a reshaped version. Why we need to reshape? Because we are going to do this. XY litho is equal to np append of sol dot grid values lit reshaped axis equals 1. So and here xy lit, litho, here this is litho 5. Okay, so this is the, okay, in here we have x, y, z, and the litho. Okay, because this is something that we need in order, this is how we export the voxels. Okay, so the centroid and the centroid and the litho value, the litho index of each cell. Okay, if you are here with me, please type 8. Okay, great. And then we can save np.save. Okay, we can save this txt output xyz litho, and then we store that as an mpy. Why we store that as an mpy? Because we can store that as a txt, but in mpy we don't. When we imported much faster, I guess, or well, or in order to save is much faster. Shift enter. Okay, great. So that will be, so if you go here to your txt to output, you have the litho here. Okay. Okay, great. If you are here with me, please type 9. If you are here with me, please type 9. Okay, that, just to mention two things. Okay, that we have a diploma in geospatial analysis, land cover evaluation, geomachine learning and surface modeling with Python, okay, that is coming. Uh, okay, just one quick. And this is this program will start the 12th of September, okay? And I strongly recommend you to take, I mean, if you want to manage, to store, to Excel all the tools of Python for spatial analysis, this is the program, okay, that you might be interested, okay. The second is why we store this as an MPY, because it's faster to with this with one line you can store this as an MPY, because if you want to store as a TXT you have to do a loop. Okay, that is why we have stored that as an MPY. And the other announcement is that the coming webinar of this one, I mean the second part, is where we are going to take this geological model and then we are going to apply to a hydrogeological model. That was our intention. That was our intention. Okay, if you are here with me, please type one. If you have any questions, do you have any questions? Okay, hope to see you in the diploma. Do you have any questions about this? Do you have any questions? Uh, what's the file format for no, the output for us is this MPY, okay? Well, we have as a VTK and as an MPY. For me, it's useful as an MPY. I haven't explored the version of exporting as a GMH. Maybe it's possible, okay? Okay, I will stop the